Alright, time for a very exciting update on the press brake. I spent yesterday working on my dad's camper, blew out a tire on it on a trip to San Antonio. And they make campers so cheap nowadays. It's a 20, I think it's a 21. It's a 2019 or 21 Prowler. And they make them so cheap now. The flooring's made out of OSB. There's no fender liner. Blew out a tire and I was only going about 60 or 65. And I felt the trailer kind of move funny. I went, what was that? And then I heard dut, 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 dut. So I mean, in a quarter mile, I got it from the left lane. There was no traffic. I just pulled out. I got it from the left lane to the shoulder, and then in the quarter mile that it took me to get slowed down and get to the side of the road, it already blown a hole in the floor. Anyway, so I spent yesterday working on putting fender liners in there, and I kind of broke them where they would go up in the trough. And I really wish I had this thing yesterday for that. Plus, there was another part that I made that it just I'm just so excited to get this thing running. It's gonna be so nice. But anyway, so I did a rattle can spray paint job on it. It's not the greatest, but it looks better than it did. And I hate how gloss black is like shows every single little imperfection, but hey, it's what I had in the cabinet, and I literally used all of it up. It was like 5 cans. So anyway, I pulled the bearing housing out of there and pulled the cog off of here, because I think what's going to happen is when I go to put this thing back together, I'm going to have to suspend this thing with a forklift, because assembled it's going to be so heavy there's no way you're going to pick it up. The flywheel alone is so heavy that you can, it's several hundred pounds. So this shaft that runs through, what I'm going to have to do is I'm going to have to loosen this collar right here, and it's going to have to slide back this way. And then because when I get this bearing housing on here, I've got to get these 4 bolts in here and get them tight, because they have to go in from this side, and then we'll be able to hold the cog in there and drive that shaft back this way to get it on there. There's the cog. That thing right there is heavy enough too. By my math, what did I say it was in the plate? I think it's 3,000 pounds just in the plate that makes this thing up, the beds and the risers. Plus those cogs, they're like a couple hundred pounds each at least. I mean, it's light enough that I can pick it up on my own. I just don't like to. So this is the flywheel, and these are the parts that I have. So this is the ring that comes off with the Allen screws on the other side. This is a plate that I cut out of 1/2 inch. This is magnetic. So I'm really counting really heavy on the fact that this will be ferrous, and I can actually weld it like it's mild steel. So we're going to center this up in here. I got a QD bushing. I got the wrong size though. This shaft, I thought it was an 1.5 inch shaft. It's actually 1 7/16 inches. So I ordered an 1 7/16 inches QD bushing, and the keyway actually lined up on it, surprisingly. There is a keyway on this shaft right there that my QD bushing can go in. So, I mean, you have to remember this thing is turned up from how it's going to be mounted, but essentially this flywheel, we also got a new sheave for the motor that is the same size as the old one that was on the motor, or close to it. I don't think it's exact, but it's close to it. But it's the same belt size and everything. These belts, I don't know how long they'll last. We'll see. But I have a new QD bushing, well, QD bushing that came with this one to go right here on this new motor. The motor is rated for 35 or something, 35 or 38 amps on a 240. So I'm going to get the electricians to install another 50 amp breaker over here wherever I decide I'm going to hook this thing up at. But anyway, so basically that motor's going to mount up there. That will turn the sheave on the flywheel. This will be welded right here, and then when you engage the clutch with these 2 air lines, this whole assembly, instead of them being able to turn independently, they'll lock together, because typically this is going to be spinning, and then when you lock the clutch in, it's all going to rotate at the same speed. So this is my air union. I got a cap. This is a cap for a DPC 13T clutch. That's why it's so much bigger, because it's for a 13 series. The one for the 9 series, like what I have, is like $900. I am not doing that. So what I have decided is, because you have inlet and outlet here, what I've decided that I'm going to do, instead of going to a machine shop or doing it myself and drilling a hole here and tapping it and then plugging these off on the ends, I think what I'm going to do to see is it's supposed to mount right here on these screws. I think what I'm going to do is let this sit right here, which this needs to rotate with the inner housing. So probably what I'm going to do is drill holes in here at the pattern for these three right here, because it's designed to sit right here on this ring and bolt down, but obviously it can't because it's too big. So I'll get screws and or bolts rather, and I'll drill the pattern on here, and then I'll come up and I'll put a stop nut on it to hold it up off of here, and I may put a sleeve on it just to give it a little bit of extra strength. Put a stop nut here to keep it from wanting to wobble too much, maybe a stop nut and a washer. And then I'm going to come out here with a 90 and look it down, and then I'll loop in and I'll offset it about like this, so you see where the inlet is and where the outlet is. I'll offset it slightly and I'll run under and I'll cross to the other side. So this one will go under and go to the other side, and then this one will come over and come to this side. That way, in theory, it should still be balanced. Won't be that big a deal. If I needed to, I could either drill right here and hit this port that's drilled through. I could drill that and tap it. This is aluminum, so it wouldn't be that hard to drill. I could drill in and tap that and just put a piece of flexible hose that comes and wraps around and goes down into the fitting underneath, or I could cut a notch in here and have a notch milled in here that it can loop and go under if I need to. We're going to see how it ties in without it. The only issue that I see is if I offset like this, this is looking across, so this one will have to go over to here, and this one will have to actually this one's over here. So that's my only concern. So I'm gonna work with it, but then this is the air union. We'll put a nipple on here, and this will suspend out here. One of my concerns is this thing is so freaking heavy, but there's no way that I can support this thing from the outside, because I have to have an air union on here and I have to have air lines running to it. So I can't put a pillow bearing out here because it would get in the way of everything. That's one of the things I'm very, very concerned about. But I mean, that bearing down there is really, this housing has got a really good depth on it, and it goes all the way through that like 1.25 inch plate or whatever it is, and it's got 4 bolts. So I mean, we'll see if it's strong enough to hold it up. But this is progress right here. This is progress. Won't be very long, and we'll be mounting the motor. And like I've said before, I want to add an adjustment so that I can adjust the tension on the belt, and hopefully that will allow me, if I put more tension on the belt, then it'll make it go faster. If I let it off, it'll slip some more and it'll go slower. And I haven't decided how I'm going to do that yet. I have this old sheave right here. It came off the old motor. I could just get a piece of shaft that's that size. I believe it's 1.25 inch, maybe 1 1/8 inch. Anyway, I could get a shaft that's that size, and I could make an idler in there if I have room for it. Otherwise, I can put the motor on a slide and it can just slide back and forth. But anyway, that's progress. I'm excited. We're getting to the point where we're getting close to having this thing running. Of course, I'll have to wire in my foot pedal. I've got this extension cord here that we're going to cut and use for the insulated 3-wire. And then I also got the 3-way solenoid valve in right here as well, which I have to read up on the wiring directions for this, but there's flow on it right there. So comes in here, goes out here, and then it exhausts out the top. So when you press the pedal, it which I think it just matters if you wire one of these pink wires. I believe one of these pink wires is normally open, one of them is normally closed, meaning that one of them will activate it to open the valve and the other one will activate it to close the valve. So I shouldn't need but one of those, and the top will just leave open, and it will mount somewhere close to the actual air union, so we don't really have a lag in response. The closer your valve is to the equipment, the better. This will mount somewhere over there. I don't think I'm gonna need this other arm that's over here. I don't think I'm gonna need that one. If I do, it's just simply gonna be so I can run an air line up. It's definitely gonna be in the way mounting the it's going to be in the way of mounting the clutch and flywheel and all that. My plan is to weld this here, and then which I'm still pretty nervous about welding that. It is ferrous. It's magnetic. I just don't know what it's made out of. I mean, a magnet will stick to it. So I believe it's milled steel, I think. So we should be good. Once this side is welded, then we'll unbolt it from the bottom. We'll take this ring out and we'll do it the other side. The reason why I'm waiting to weld that is because I want to get this proper size QD bushing here, so that it will actually hold it centered on the shaft. Right now I just have it in there to see what it looks like, but I want the right size QD so it will hold this whole thing centered on the shaft, because if there's one thing I don't want, it's for this whole thing to be out of balance. And even then, what I'm probably going to do is I'm going to get a piece of angle iron or something and attach it somewhere on here on this vise or on this stand where it will be consistent with this. Because you can see it's moving a little bit, but that's down there at the base. So I think if I tack a piece on, like maybe on that tab, that ground tab that I have, bring it up, then I can run out and I can put a feeler here, and then I can also put a feeler on here somewhere to make sure that when this spins, that it's all true. Because what I don't want is for this thing to be the slightest bit off center and out of balance. It's got to be as close as I can possibly get it with what I have, because this is going to be spinning at 2,000 RPMs. And if this is at 2,000 RPMs and something is off, it's going to be disastrous. So that's what I have to look forward to. I'm up for the challenge, but as you can see, probably with that QD bushing in there, it's probably still going to move a little bit. But anyway, that's a challenge for when I get the proper size QD bushing in. And once that's in, I can get this welded, and then we'll be ready to mount it. And then we'll figure out what to do with the air union and everything like that. It's designed to be flange mounted or nipple mounted. And we're just going to do nipple mounted. This is 1/4 inch. And this is 1/2 inch, I think. So probably have to put a bushing on there or something, reducer of some sort. get that down in there, have it stand off, and then we'll have an air line, of course, that runs up here. It'll be a flexible line that comes from here and goes to that solenoid valve, wherever. So we're close. We're really close, and I'm excited. After that, it'll be getting dies and tooling, and that's going to be a build that I'm not looking forward to at all, because I know that's going to be high. There was a guy on Facebook that was in Elgin, Texas, which is about 3 hours from here. It's down close to Houston. He was in Elgin, Texas, and he had lots of tooling and stuff. And I messaged him, but I never heard back from him. He had a load of it that he said $1,700 for all, but I never heard back from him to know if he still had it. And to be quite honest with you, even if he did have it, I wouldn't be able to afford it right now as it is. I'm going to have to work my way up to getting tooling, which one of the plus sides is there is a seller on eBay that has a lot of die tooling that I'll probably hit up when it comes time and get me some tooling from him. But I mean, I'm ready to get this thing rocking and rolling so I can start punching stuff out with it and use it, make some money with it. So till next time, like, share, comment, subscribe.